Hi students, this is Alex here. In this video, we are going to find the half-range Fourier sine series for the given function f of x is sin h ax in 0 less than x less than pi. Now the expansion formula is f of x equal to summation n equal to 1 to infinity bn sin nx. But bn can be found by using integral 2 by pi integral 0 to pi f of x into sin nx dx. Then we are going to replace f of x. So 2 by pi integral 0 to pi sin h ax into sin nx dx. Now we are going to apply a formula for sin h ax. Sin h ax is e power ax minus e power minus ax by 2, and outside we have integral 0 to pi as a limit, and we have a term 2 by pi, and on the other side we have sin nx dx. So this 2 and 2 we can cancel. We can take this as 1 by pi integral 0 to pi. I will expand this. So e power ax into sin nx is one term dx. Again 1 by pi integral 0 to pi e power minus ax. Since there is a minus sign, so we keep minus here, and this is sin nx dx. We are going to apply the basic integration formula. When you have integral of e power ax into sin bx, this formula is e power ax by a square plus b square into a sin bx minus b cos bx, and we will have plus c, but here we don't put plus c because we have limit. So applying this formula for both the terms, so as the first part we have 1 by pi, then e power ax by a square plus, in place of b we have n, so plus n square into a sin bx, so sin nx minus n cos nx. So this is 0 to pi. So let's put separately 0 to pi here. Then again minus, we have 1 by pi. Now we have e power minus ax by a square plus n square, and this will become minus a sin nx minus n cos nx. Then we have 0 to pi. Now applying the limits, for the first term we have 1 by pi. This will be e power pi x by, e power a pi, because x is replaced as pi. So e power a pi by a square plus n square. Here it is a sin n pi minus n cos n pi, minus, when I apply the lower limit, e power 0 is 1 by a square plus n square, sin 0 is 0, then minus n, cos 0 is 1. So we have only this much. Now coming to the second term, we have to apply upper limit. So this will be e power minus a pi by a square plus n square into a sin n pi minus n cos n pi, then minus, when I apply the lower limit is 0, so e power 0 is 1, so 1 by a square plus n square, then again sin 0 is 0, cos 0 is 1, but we have minus n as a term before the cos nx. So after applying the limit, sin n pi is anyway 0, even this will become 0. Cos n pi is minus 1 whole power n. So this is 1 by pi e power a pi by a square plus n square minus n into minus 1 whole power n. This is the first term, this is the product. Then we can cancel this minus and make it as plus. plus n by a square plus n square. Then second term minus 1 by pi e power minus a pi by a square plus n square into minus n into minus 1 whole power n, then again plus 1 by a square plus n square. Now we can take 1 by pi totally common from both the terms. So the first term will become minus n minus 1 whole power n e power a pi by a square plus n square, then plus n by, even here there is an n, so n by a square plus n square, then minus sign, so we take minus inside, e power minus a pi into minus n, so I can make this as plus again, so n into minus 1 whole power n whole divided by a square plus n square, and last term is minus n by a square plus n square. So here we can cancel these two terms because they are same term with opposite signs. Now we can write 1 by pi and common denominator we can take out, that is a square plus n square. After taking this out, we can also take this n common. Actually we can take minus n common. After taking minus n common and even minus 1 whole power n common, we left with only e power a pi. We have taken the minus common. So this term will become minus e power minus a pi. So after taking all the common terms we have like this. But this is once again sine h a pi. So minus n whole minus 1 whole power n by pi into a square plus n square into sine h a pi. So this is our bn. So after finding this bn, we are going to substitute this in the expansion formula. But one thing, when you have divided by 2 only, we can apply sine h a pi. I write the formula here, that is sine h ax is e power ax minus e power minus ax by 2. We need by 2 here, but we replace it here. So we purposely multiply and divide by 2 here. So this will become sine h ax. So outside there will be 1 2 also here. Now coming to the expansion formula, f of x is equal to summation n is equal to 1 to infinity bn, which is minus 2n minus 1 whole power n by pi into a square plus n square into sine h a pi into sine nx. So all the constants can be taken outside the summation, minus 2 by pi, then sine h a pi. After taking this common, we have summation n is equal to 1 to infinity n into minus 1 whole power n by a square plus n square into sine nx. This is our expansion formula. I mean the expansion of the given function f of x.